the nanomaterial and characterization technique. Here in this, there are two terms. One is with respect to the nanomaterial, the another one is the characterization technique. The first thing what we have to learn is the size of the material, which is nothing but the nanomaterial. The second part is nothing but a characterization technique. The material what we are obtaining it, that size it has to be measured. And what is the size? That size, is it nano or not? That it can be characterization or the characterizing. It can be done by using so many methods. Now, as you know the term, the nanometer, which is nothing but 10 to the power of minus 9. Now, the scale of the nanomaterial. The scale of the nanomaterial, which consists of the three things. One is nothing but the molecular, microscopic, and as well as a macroscopic. In the macroscopic, there are three entities are there. One is with respect to the child, housefly, and as well as the human hair. And in the microscopic, which is nothing but a blood cells, the nanostructures, which is nothing but the virus and as well as the nanocarbon tube, and molecular, which is nothing but a water molecule. See, if you start comparing all these, the size it starts decreasing 1 meter to the 10 to the power of minus 10. Now what we are discussing is with respect to the nanostructure, or it may be the nanomaterial, which is in the range of 10 to the power of minus 9. Even this also represents the same thing. The size of an ant, which is somewhere around 5 mm. The size of the mite is around 200 micrometers. Next, the size of the air, which is nothing but 10 to 50 micrometers. Then the MEMS, what we are discussing, is around 10 to 100 micrometers. Then the blood cells is nothing but 2 to 5 micrometer. Then coming to the, either it may be the DNAs or it may be the carbon nanotubes, which is around 2 to 15 nanometers. Now, first we will see what is the nanomaterial, and the next part is nothing but nanomaterial technology. Nano means it's nothing but 10 to the power of minus 9, but high potency and emerging with a large application precising through all the discipline of knowledge leading to the industrial and as well as the technological growth. In other words, the nano-sized structures needs to be a magnification of 10 millionth time before we can easily appreciate it a fine detail with a naked eye. Nanotechnology is already having its impact on the products or devices or novel foods or medical devices or chemical coatings, or even in the personal health testing kits, even the sensors, and so many applications. What is nanotechnology? Nanotechnology is a catch-all phrases of materials and the devices that operates at nanoscale. In the metric system, the measurement nano, which is equal to a billionth, and therefore a nanometer is 1 billionth of a meter. Now, nanotechnology is a multidisciplinary science that has its root in all the fields. If you take an example, either it may be a mechanical, or it may be a chemical, or even it may be a physics, or even in the electronic and electrical industries, depending upon the type of the applications, such as either it may be a colloidal science, or it may be device physics, or it may be a supra molecular chemistry, or even the nanomaterials in the case of the mechanical engineering. Nanotechnology is a fundamental enabling technology allowing us to do a new thing in almost every conceivable technological disciplines. Nano means which is nothing but a 10 to the power of minus 9, but of high potency and emerging technology. The manipulation of these nanomaterial to develop a new technology improves on the existing one. They used in a wide range of applications in the field of the electronic medicine, mechanical, energy, and even more. Nanotechnology is the creation of the useful and a functional material devices such as systems that controls the matters of the component. Emergence of the nanotechnology. The emergence of the nanotechnology has led to a design, synthesis, and as well as the manipulation of the particles in order to create a new opportunities for the utilization of the smaller and more regular structured. In recent years, nano-sized metal oxide particles have got much attention in various fields in the application than that of the micro. The best examples are nothing but optical, electrical, magnetical, and catalytic, and also even in the biomedical properties, as well as with their high surface to volume ratio and specific affinity for absorption of inorganic pollutants and degradation of the organic pollutants in aqueous systems. Nanosize and its properties. See, the figure shows a nearly all properties like hardness, strength, durability, elasticity, melting point, density, thermal conductivity, thermal coefficient, and even diffusivity, etc. Why should the material behavior varies significantly as the size reduces? That's a major question what we are discussing now. Nanostructured materials are composed of the grains and as well as the grain boundaries, which is in the size of a nanometer. The few thousands of an atom within each grains. If you take an example of the mechanical properties, the ductility, the strength, diffusivity, toughness, hardness, coefficient of thermal expansion, and all those things will improve the mechanical properties of a given material. But the density and elastic modulus and conductivity starts decreasing it. Now, the change in the property of a nickel as a grain size in the change of 10 micrometer to a 10 nanometer is one of the example. The property is nothing but the hardness increases 5 times than that of the micro. Then the strength is somewhere 3 to 10 times it increases. The wear resistance 170 times increases. Then frictional coefficient reduces to half of that. The corrosion resistance reduces, and even the magnetic properties, the lower corrosivity and as well as saturation magnetization reduced by 5%. The electrical property, the resistivity increases by 3 times. Like that, if the particle size is varied from micrometer to nanometer, most of the properties is increasing, and also there is a great improvement in the mechanical properties. The nanomaterial preparation. The nanomaterials, it can be prepared in two different approaches. The two different approaches are nothing but the top down approach and as well as bottom down approach. Top down approach. Top down approach refers to the slicing or cutting of the block material into a nano-sized particle. They are similar and really on either the removal or the division of the bulk material to form a appropriate smaller material. Bottom up approach. The bottom up approach refers to a method where the devices creating themselves by self assembling. This is especially by means of a chemical synthesis method. In the bottom up approach, atoms, molecules, and even nanoparticles themselves are used as a building blocks for the creation of the complex nanostructured materials. Bottom up approach is cheaper than that of the top down approach, but getting a control over the method is very difficult.